All right, good afternoon. I appreciate everyone for sticking around till the end of the day. Or appreciate everyone I guess I feel privileged to be the last presentation of this conference. I am Hideyuki Terashima. I am an environmental geologist with the Illinois State Water Survey. I primarily work on our wateroperator.org program, which is our more operator-focused program. It's a technical assistant and outreach-focused program for water and wastewater operators. But I do work with GIS a lot, which got me involved with this project, intended to help professionals working with private wells and on-site wastewater systems like septic systems. And I'll be highlighting, that project today. And this project is funded by EPA, as Steve mentioned, as part of the agency's efforts to help communities with significant pollution challenges, as well as like aging infrastructure issues to access federal funding. For example, the 2021 bipartisan infrastructure law funding to address some of those concerns. And RCAP was selected as one of the 29 environmental finance centers to help deliver that technical assistance. And we'll be working with them as partners to develop an online interactive mapping tool that will help RCAP find those communities that are in need where they would actually be able to use federal funding to extend their sewer lines where there's a lot of septic systems or extend a distribution system line to areas where there's a lot more private wells, but again, where there's a lot more environmental issues, public health concerns, where they shouldn't be drinking the local groundwater or shouldn't be using their septic system. So this will be the outline for today's presentation. I'll start off by providing a little bit more information about the project itself, highlighting the project goals, where we're currently at with the project timeline, since this is still an ongoing project. For the project, we originally wanted to develop a map for all 50 states, but we kind of realized early on that because of our staff size, project timeline, funding issues, as well as the main concern, which was state availability from every single state, we kind of had to limit our number of states that we're going to actually develop maps for. So we kind of shrunk that just to developing maps for 10 states, which we later expanded to 11 states because we found out that Florida actually had a great septic system data set. So I'll highlight how we went about choosing those states, as well as kind of highlighting how we plan to use the data that we gathered. We also gathered a lot of other additional data sets like environmental data sets, socioeconomic data sets, demographic data sets that will help us kind of identify more underserved, disadvantaged communities, since those were the communities that we kind of wanted to focus on. I'll actually show examples of our work in progress map that has some of our data points added on there. And I'll be touching on some of the what's going to be happening next for this project towards the end of this presentation. All right, so a little bit more information about this project itself. It's a 5-year project. We started it back in 2023. Again, we're going to be developing maps for RCAP, which will, again, be used to identify communities, specifically disadvantaged and underserved communities, where there's a higher concentration of private wells or septic systems that, again, would be beneficial for them to be connected to centralized water and sewer services. We're going to integrate additional data sets, mainly focusing on publicly available data sets, like socioeconomic data sets, geologic data sets like what aquifer private wells are drilled into, what are the soil conditions for local septic systems, or where they're sited, just to get a better understanding of whether they should be actually located there or not. We're going to also look at demographic data like where there's a lot more higher poverty rates, higher racial discrimination rates, just a lot of interesting EJ information that we can actually utilize and map out. Once the data sets are reviewed, we're going to be developing a report that will outline the criteria to identify the target communities that we kind of want this project to help out. These communities will ideally be close to a municipal boundary or will be close to a municipal boundary that's already served by a water system or sewer system because, again, we're trying to extend those lines. If it's a very rural area, that's not going to be possible most of the times. So again, we're going to be focusing on those areas where it's actually will be possible to extend those services. The report will also include a summary of what we learned from each individual state, which was able to provide data from us. We actually followed up with them, asked several survey questions just to get a little bit more information. But we're going to plan to develop a report that we hopefully will be interesting to the public as well as EPA and RCAP. Here is the summary of the current project timeline. So for the first 2 years, between 2023 and 2025, we focused on identifying the 11 states that we're going to be doing further analysis. So this mainly, or the effort mainly involved for this part was to, again, identify which states had the highest quality data sets, specifically location data sets of private wells and septic systems. We're also developing a state selection methodology document currently, which will outline, again, how we went about choosing those 11 states. And then the next 3 years, between 2025 and 2028, it's going to involve us developing those state-specific maps. We're going to be working together with RCAP to utilize those maps to identify those target communities that would benefit from this project, and hopefully do further assessment if it's necessary. And we're hoping to develop a public-facing online interactive mapping tool by the end of the project during 2028. So a little more information about what has inspired us to start this project and how we expect the project to be helpful for those communities. So underserved communities, they're usually defined as areas where there's historically had limited access to resources, opportunities, and even services due to, again, socioeconomic barriers as well as systematic inequality issues. These areas are often higher in poverty rates, they're more rural, they have a lot more health disparities, or areas that, again, have experienced a lot more racism in the past. Many of these communities also have issues accessing federal funding issues because, again, they're often neglected. They don't have the capacity to be able to go get funding. And a lot of times we know that if there's a lot of SRF funding available, states tend to prioritize bigger systems where, there's a lot more population there. So again, we're trying to help these disadvantaged communities that are having public health concerns as well as concerns with aging infrastructure of their private wells or septic systems. We're also hearing a lot more stories about septic systems failing in more rural coastal areas where there's sea level rise is negatively impacting those systems. They're leaking the septic tanks are leaking, causing more environmental hazard issues within the coastal communities. Even for private wells, we often hear that these disadvantaged communities are located near industrial areas, more industrial areas, next to an Air Force base where there might be a lot more potential for PFAS contamination or, other contaminants to enter the groundwater, which might impact private wells. And we also hear a lot about, areas where there's fracking. People are concerned that their wells are getting contaminated because of all the fracking going on. So we're gonna be looking at all those data sets as well. So our goal as part of the national EFC is to help connect these communities with those federal funding opportunities, and hopefully they will receive the technical assistance that they need. And the interactive mapping tool that we're going to be developing will again aid RCAP with helping, or as well as our partners, to help identify those communities that would benefit from additional assessment to implement alternative water or wastewater services. So to start the project off, we first needed to evaluate what level of data sets were available from each state. We knew several states had really good data on private wells because, especially Illinois, we're from Illinois, we house all of our well logs. We knew we had a decent or high quality data set of well logs. But again, for this specific project, we really need that location information, ideally XY coordinates of those systems, so that we can actually identify clusters of homes with private wells that would actually benefit from this. Because even if there's a single private well that's located in a disadvantaged community, it won't be beneficial just to extend a sewer line for just one home. So we really needed to find those clusters that are located in those disadvantaged areas. So we knew this was going to be a pretty extensive, time-consuming process. So like anyone does, we hired a GIS intern to do the majority of work for us during that first summer. So he actually ended up doing a lot of the legwork for us, helping me out, contacting a lot of the states, starting our GIS map, getting all of our data together, making sure that we can actually work with it. So we really appreciate all his work. I'm just gonna give a shout out. Thanks a lot, Wayne. You're the best. Hope you're doing well. He actually worked for us a little bit over a year, but he ended up getting a different job and he's down in Florida now. But he really did help us with this moving this project forward. So we checked every state permitting agency's website, looked to see if they had a GIS clearinghouse where we can download shapefiles. We also looked for any kind of a searchable database or like a well permit database where you can enter an address, enter a county, where it will spit out a list of those systems. And a lot of times you can actually download that data as a CSV or Excel files, which again made it easier for us. But not all searchable databases had that option. So for some of the more cumbersome databases, we had to scrape data using tools like Python. And for data we got where the coordinate system was, or the location information data format wasn't something that we were able to use, we used tools like GeoPandas to convert those to a coordinate system that we could use. And for states that didn't have publicly available data, we did reach out to their state agency in charge of well permitting to see if data was available. But again, sometimes they never got back to us, or sometimes they didn't even have data available. So we're kind of limited in that factor. But that's what we did for the private wells, and we also did that we did the same effort reaching out to state agencies that permitted septic systems as well. So what did we find out? Well, for private wells, we were able to collect some level of data from 39 states. The data came from majority state agencies, but some did come from geological surveys as well. Ours came from the Water Survey as well as the ISGS. This is highlighted in the challenges section on this slide as well, but several states only had partial data where they were missing data from certain counties, or maybe they were missing data from older records. We did try to confirm this with each state agency whenever we did our contact efforts, but we also compared our data set, or our data we gathered, with the EPA's estimated number of private wells 2010 data, which several of you guys have also mentioned throughout this conference. But that data was actually published a couple years ago, and we went through the process of counting the number of private well data we got from each state and compared it with EPA estimates to kind of see which states had the most reliable data set. I know it's not the best way, but for our sake, this was the EPA estimate was like the best data set we could use. So we did that comparison. I actually mapped it, or made a table comparing which states had ranked the highest, comparing their available data with the EPA estimates. As you can tell, Colorado had significantly more wells compared to the EPA estimate, but there were a number of states that had public records close to what EPA had, which kind of helped us decide the states that we wanted to look for. Some of the other challenges we noticed were some agencies only offered a bulk well record, so that included oil and gas wells, as well as any other industrial wells where we had to filter that information out. Some agencies only also offered scanned PDFs of their well logs, which we unfortunately weren't able to use because we didn't have a way to automate the process of just getting the location data from the scans. And I'm a geologist, my handwriting is pretty bad, but some of the older well logs, the handwriting is pretty illegible, and they're kind of fading, the ink is fading too, so we just decided not to bother with that. But again, we did find a decent number of states that we could use for this. On the septic system side, however, data availability was much less. We were only able to get data from 11 states, and not all of that data was usable. Again, majority of this data came from state agencies. So the problem with the septic system side is that first, majority of the states lacked data. Many suggested that we should reach out to individual county health departments because that's where the permits are located. But for states like Texas, where there's, I believe, 254 counties, that would have been an arduous task. We didn't have the manpower, we didn't have the funding, or the time to actually go through that process. We may eventually want to consider it, but if we do, we're going to hire at least like 20 interns to work for us. So additional challenges that I wanted to highlight in this table, or that I wanted to highlight, is that, oh yes, a lot of states had inconsistent data formats. So again, the best coordinates, or the best data format we could have used was the XY coordinates. But some states only had street addresses. Even for street addresses, it wasn't a complete street address. It was just a street name. So we could have gone through the process of geocoding those street addresses, but we figured that would be a little bit challenging and time consuming, so we decided not to. Luckily, the 11th state we chose was Florida, and Florida ended up having 1.7 million septic system counts. Which again is a high quality data set, and we're excited to actually do further analysis for the state of Florida. So after we quantified the location data from each state, we ranked them and chose a state from each EPA region. Again, that had the highest quality data. We kind of went with the choosing one state from each EPA region because we're funded by EPA. We figured it'll look for EPA if we chose one from each region. So private wells, we're going to be mapping out these 8 states, and for septic systems, we're going to be mapping out those 3 states. So after we figured out which states we'll be mapping, we needed to identify what other data sets we could use for this project to make it work. On this slide, I have a list of the national data sets that we utilized, which was pretty important for this project. So the first one listed is the 2010 EPA estimate of private wells from each state. Again, this just kind of helped us identify which states, compare the public data we've collected with EPA estimates. We also utilize EPA's community water system service area boundaries because, again, we're trying to find systems that are somewhat within a municipal boundary or close to a municipal boundary. And this data was just released, I believe, last year, and it is pretty decent. We did compare that with the census Tigerline shapefile, which has an urban area coverage. And we kind of compared to see how those two compared, and they were pretty similar. We might have to do a little bit more analysis for different states, but as far as we can tell, we were planning on utilizing the community water system boundary data to identify, again, majority of those systems that might be able to be connected to a distribution system. Other data we got from the Census Bureau, we got data for median household income for 2010 or 2021 for both the census tract level as well as the block group level. We also got ethnicity data, like areas where it's considered majority non-white, again, for both block group and tract level. And from EPA, we did try to get data from EJ Screen. EJ Screen is a great tool. Well, I should say was a great tool. It has a lot of socioeconomic data. It has a lot of, it even lists disadvantaged communities. Unfortunately, it is no longer on EPA's website, but there is an archive of it that is available on Public Environmental Data Partners website. And if you've never seen it, highly recommend it. There's so much interesting information on there. They have like cancer rates. I believe they have cancer rates, or at least some data related to health disparity that we are hopefully eventually going to incorporate in our maps as well. And Energy Justice Network also has a EJ screen, or they have the Justice Map, which is similar to the EJ screen. It's a little bit less, there's a little bit less data on there, but again, it highlights a lot of the disadvantaged communities, areas where there's higher poverty rates, and just, again, much more useful information. And for state-specific information, for this presentation, I'm just going to focus on Illinois and Delaware, as those were the 2 states that we kind of started developing maps for. For Illinois, which was one of the states we looked for private well data for, we primarily focus on locating more source water protection related data. Illinois EPA actually manages a geospatial clearinghouse, which hosts a lot of great data sets like remediation sites, active landfill sites, Superfund sites, leaking underground storage tanks, and just much more environmental data sets. We also looked on ISGS, the Illinois Geological Survey's website, to look for any geology-focused data. They have a lot of great maps and coverages, like geologic susceptibility, areas that are currently being mined, karst geology, sinkhole locations, kind of any geologic data sets that might help us identify private wells that would be that are at risk. For Delaware, which was one of the states that we chose to look for septic systems, we looked for data more relevant for septic system siting. So the Delaware Geo Survey, we were able to get water table, depth to water table data from the surface. We also were able to get aquifer recharge potential data, superficial geology data, like what are the surface soil conditions. And Delaware DNR, they also had a lot of great data sets like septic soil borings for a statewide coverage of septic soil borings, which also includes perk rates, as well as wellhead protection areas. So again, data sets that might help us identify areas where septic systems may not be ideally should be located. But again, we'll continue to look for more data sets, but these were the primary data sets that we started integrating into our maps. So here is the actual fun part, visualizing the data sets that we actually collected. So we primarily use ArcGIS and QGIS to work with our data, doing geospatial processing, like removing outliers, data points that were outside of the states, data points that seem like, this well is, this doesn't look like a well, this shouldn't be here, just any way to clean up the data set itself so that we can actually do some geospatial analysis. And once the data set was cleaned up, we uploaded them onto ArcGIS Online, created individual web maps for each state, and integrated them into, I'm not sure if you've heard of it, but it's called ArcGIS Experience Builder. It's just a platform where you can consolidate all your web maps into a one link so you can compare all different state maps at once. So this is the map that we have for Illinois. The blue dots represent private well locations. It's still a work in progress, but I did want to highlight some of the features that are available on this map that users can interact with. These are majority filters that you can turn on and off to display or remove certain data points. But starting on the right side, we have, it's kind of hard to see. Oops, I don't, oh, good, I didn't advance the slide. Oh, right, I'm supposed to point it here.
Either one should work. You just gotta hold it right.
Oh, there we go. So these on the right side are more of the socioeconomic and demographic data sets. So at the very top, there is a filter widget to turn on just private wells that are located in majority non-white areas. And the following, the widgets beneath that are for more income-based data sets. So, if you want a private well in an area where the median income is $50,000, you can turn that on and it'll show you the wells. And this is actually the view that I have right now. These are, you might have thought this seems like way less private wells than you would expect from Illinois. These are just wells which are located in census tracts where the median income is less than 50,000. Then on the left side, we have more of the environmental and geology-focused data sets. So this is where you can turn on data sets like where are leaking underground storage tanks, where are the karst areas, the EPA's community water service boundary data, just all the additional data sets that we've included. And we also have a legend on the left side, and it does automatically count how many private wells are, the counts of the private wells depending on your search criteria. So let's say we went ahead and turned on the majority non-white filters for this. Once we do that, as you can tell, it does shrink your data points much smaller. The interesting thing I noticed that majority of the data sets in central and southern Illinois are gone. Most of these data points that are showing up are more urban areas like up by or south of Chicago, where we have known that it's a historically low-income majority non-white area. But we do see some wells, located by eastern St. Louis, more urban area. Again, more I would consider more disadvantaged. But other places scattered around the state. So this is the kind of filters we can use to start looking at those target communities to identify, again, whether this will be in any area that would benefit from extending a distribution line. But in this is it's harder to see just from the statewide level. So if we zoom into just the Chicago Heights area, this is what you'll see. On the right side is the census tract level data. So I know it's a side-by-side comparison of the census tract data and the block group data, but I did want to highlight that we do have an option, if you can see that slider. Hold on, let me try. This slider right here, you can move it between left and right to switch between the census tract and the block group level data, so you can seamlessly just look at the data sets for both of them. But if we look at the Chicago Heights area, we can see that there is a cluster of wells located around here. And according to the tract level data, this is an area where the median income is less than 50,000. But if we switch it over to the block group level data over here, we don't see those wells show up anymore. It's because that area, this smaller area, is actually the median income is actually around 72,000. And that actually made sense to me at first because when I searched this area on Google Maps, there's a really nice new school right next to this community. So it didn't make sense to me that this would be considered a low income area. So in this case, it's really important to switch between the tract level or look at both the tract level and the block group level to actually identify or to narrow our search a little bit more. So for this example, we would be more interested in looking at communities like there or communities like there, where the block group tells us that the median income is less than 40,000. Now that we actually identify several neighborhoods that we would be interested in, we can turn on the other data sets. So the bright green overlay that you see is the EPA's Community Water Service boundary data. So if we turn on this data set, we can see that the areas that we were just looking at, this area as well as this area, isn't served by a water system. Now, again, this is an estimate. We'll probably have to do a little bit more analysis to actually confirm that this is correct, that they're not actually being served there. But if they aren't, this might be a neighborhood, neighborhood that would benefit from this project. And we can also turn on additional environmental data sets like underground storage tanks, which are represented as those red dots, just to see if there are any environmental concerns around those neighborhoods. And we do see several red dots popping up here and there around those neighborhoods, which might indicate that these private wells is at a higher risk of contamination. But again, we're going to try to look at the whole state. We're going to try to, again, identify areas that would be more susceptible, areas where funding would be more warranted. This is the map we have for Delaware. Again, this is for septic systems. The locations are represented as brown dots. We're looking at this map right now as at the block group level, and it is also set as less than 50, or areas where the income is less than 50,000, and also majority non-right. So normally, this whole state would be covered with data points, but again, just limiting, using those filters, we can limit the number of systems we might be interested in looking at. And let's say we zoomed in on this cluster located in the southern area. So here, I zoomed into that area and I turned on some of the additional environmental data sets. So on the left side, we have the depth to water table data set on there. And you can tell that there's a lot, and the red areas represents less than 2 feet of water, or less than 2 feet from the surface to water table. And there's a lot of red areas around this region, and it looks like a river, right? Which makes sense because it is a river. It's originating from Seaford, Delaware, which is the community right around here. And at first, it looks like there's a lot of systems that are on that red area, but if you zoom in, there's actually not that many, but there are still some systems that are actually located in an area where the depth to water is less than 2 feet. And we know that those are sites where conventional septic systems wouldn't be, or isn't an ideal condition for conventional septic systems. On the right side, I have this is when we turn on the wellhead protection areas. So again, it kind of just gives us an idea of which areas might be a little bit more sensitive, where septic systems might not be suited. So looking at this data set, it's harder to tell since the wellhead protection areas are smaller, but like communities down here where there's a huge cluster of septic systems, it's right next to the wellhead protection area. That might be an area we might be a little bit more interested in looking into. So before we started mapping all the data, we did go through the efforts to contact each state. Again, to see if they actually had data, whether, or whether they had data publicly, whether they had data that could be shared with us that was more internal, that could be used for this project, as well as, if we actually had to purchase data. Luckily, we didn't have to for this project because by the time we contacted each state, we had a decent number of states that had high quality data sets that we could do this project. But I believe only around 2 to 3 states actually gave us an option to purchase data. But after we selected 11 states, we also developed a list of survey questions that were shared with those individual state agencies. These were more extensive questions like, what are some of the challenges you're experiencing? Are you aware of more areas that are considered disadvantaged communities that we should, look into? Are you aware of any additional environmental data sets that we should be looking for this specific state? Just a bunch of any information that they might have wanted to share with us. And we sent that survey out. We got several replies out of the 11 states we chose. We're hoping to complete that and include in a report that would be shared with EPA. Gotcha. And here are some of the challenges that we heard back from the states. So if agencies had older paper records, many mentioned that they lack the funding, they lack the manpower to digitize them, but a lot of them mentioned that they do eventually want to do that, which is great to hear. We hope that they get additional funding for that. But on the septic system side, many agencies mentioned that they had difficulties working with local county health departments to get data because permits are usually stored there. A lot of older or less affluent counties were still using paper records. Some counties that were receiving state funding might have actual GIS data or better data that will be shared with their state, but that's probably because they're getting funding and they have stricter reporting requirements. It just depends on the county itself. Many states also said that they had variability in permitting requirements. So for example, North Dakota, you don't need a well permit if you're only pumping less than 12.5 acres per gallon per year. So for those states where we know, or even some states say that we only retain records for 5 years and we just toss out older paper records. So for those states, we end up not being able to do analysis because we figured that there's a lot of systems that would be missing from those states. Many states also had mentioned that there was issues of inaccurate location data. So, we've experienced this too, where well drillers will only list the center of a PLSS lot because they're too lazy to actually get the actual coordinates. So that issue, we also had, we kind of had to omit some of the data points because we knew that if we saw like 20 data points stacked on top of a block group, we figured that, that was inaccurate data. So we kind of have to get rid of them. And finally, many states just mentioned that they lacked funding. They wanted more staff. They have a lot of projects they want to implement. And we heard it from you guys as well. So funding is a huge issue as expected. So to wrap this up, here are the next step of this project. We're going to continue to look and integrate data sets that from the 11 states that I mentioned to develop the criteria to assess areas of interest. We'll also continue to reach out to individual states to, again, learn a little bit more from them, hear stories, get more useful information that we can include in a report. And we do eventually want to do this for all 50 states. Again, I'm sure not between this project period, but if you would like to talk to us more about this data set, definitely reach out to me. We're focused on finalizing the 11 state-specific map right now, which RCAP is going to use. We're going to hopefully try to get that done by this year or the next 2 years, and we'll have our final public-facing online interactive mapping tool during 2028. So that concludes my presentation. If you're aware of any state information data sets that we should be looking at, definitely reach out to us. We want to hear from you. We want to try to make this map a more high-quality, useful tool. So thank you for your time. I'm happy to answer any questions if we have any. And I do see that Slido slide, so let's do it. Do you have any thoughts, plans for possibly incorporating logistical aspect as well? Example, nearby public water system, max water service capacity areas, mandatory high ordinance. Yes, we do want to incorporate stuff like that. Again, like for data from public water systems, it's going to be harder to find, especially public data sets. So first we're going to have to figure out where we can get that data from. And again, we're going to have to figure out whether we can actually share that information or display that publicly.
That could also be something that RCAP goes and does manually.
Right, that might be somewhere where we'll tell RCAP, this is a region we want to look, this is the kind of data sets that we're trying to implement or trying to get, can you get it for us? So we're trying to work better with them as partners as well. So our private well data sets with just their locations of the property, not necessarily the well specifically, but zero construction info also used for this project. Yes. We would say that location data is our main primary data sets that we're looking for. Again, if there is a depth to, or depth to the well depth, what aquifer they're in, that definitely helps us more with doing further analysis. But definitely just having their location data, that can help us identify those communities. If neighboring communities have better well logs, again, that we can kind of extrapolate that they probably share similar geology, their wells are in the similar aquifer. So any location data is great for us. For the well data sets, is info such as well type, def, repair? Oh, did any states have hesitation about this homeowner data being mapped? Are point addresses repressed? Oh, sorry. So we primarily, again, focus on getting data publicly. So like public-facing data portals, we try to get data from. For states that actually provided us data where their data wasn't public, we did make sure to ask them, like, can we use this for this project? A lot of times they were more than happy to share that data for us to be used for this project. So it wasn't really an issue for our part. For the well data sets, is info such as well type, def, year built, repair also included? Oh, so yes, if they do include that information on our map, if you click on any single data point, you can see all that information, or at least currently you can see all that information. But when we have our final map created, we will try to consolidate the information. So even a regular homeowner can look at it and kind of identify like, oh, this is my well. Oh, what's this extra information that means nothing to me? Well, we're going to try to remove all that information as well. So yeah. Again, if you have any data sets, reach out to us. We'll be more than happy to talk to you guys.